Welcome back to lecture 1. And I'm calling this course Stats 1 from an elementary point of view. It's all probabilistic reasoning. I guess the prerequisites end up still being, can we count? And there's different kinds of data that we need. This will be part 2 of lecture 1. And I split it up because the first part was getting our feet wet. And we had a bag here of Lucky Charms. Magically delicious according to the jingle. We have stars. We have whatever these are, look like little cookies. We're doing land and earth, which is an example. You can hear it. There we go, in the bag. It's in the bag. That's binary data, 0-1 data. You're on, you're off. That's how most computers work. Actually, almost not quite. Signals are peaked on and then dragged down. Anyways, we're not electrical engineers here. No, sounds like fun though. More like popular mechanics at this point. Part 2 will take what we did in part 1, so we need to go back and look at that and go through and do the same procedure, but we're going to put it in Excel. Why? Because that's our computing platform. We want to play with this a lot more. As I looked over the whiteboard, it's pretty messy. I want to tidy it up a little bit. For those of you who are in the R environments, tidy has a very special meaning. Yes. So let's let me share my screen. Get us back into this. You can see me up here. I'm going to stay up here for a few more minutes before I reduce myself in size. This is what we did in part 1. We went through a 5-step process that we're going to use all the time throughout the course. We're going to get very creative about how we count, however, as we go through the course. Right now, we're just counting how many ones and how many zeros, effectively, how many lands, how many waters. We posed a question. We formed an hypothesis. Actually, we formed 5 hypotheses, parameterized by a statistic. The course is probabilistic reasoning using statistics. Here is a statistic. And we're also going to assume prior knowledge that, sometimes you'll see 0 proportion, sometimes you'll see 100% proportion. It's almost oxymoronic, isn't it? 25, 50, or 75%. All nice and evenly spaced. And I think I also mentioned you can make these random numbers in between 0 and 1 inclusive. Yes, okay, fine. We have a fake world here. Fake science, like fake information. Not really. This is a representation that a lot of people would, I believe, agree is true. Oblate, spherical. Yeah, where even the beach ball looks like it's an ellipsoid, barely, which is the current model of Earth. We would sample this 3 times, and here's our samples. We counted the number of ways in which we could find water in an observation given a particular hypothesis. We would then infer plausibility. This is relative plausibility. We used a counting principle, very simple counting principle. Pretty familiar with. I think I first encountered it when I was 5 years old, playing Jim Rummy with my grandmother and her 2 sisters, speaking 5 different languages. Yeah. And here we created a structure to think about this problem. And we're going to transpose this structure into Excel or R or Python or Fortran. That would be great fun. Or my all-time favorite is APL2. Absolutely. Okay, more stories about all of those things later on. We have a nice little visual. That's the visual of the 5 hypotheses, using, of course, the charms from the bag. And our problem is binary. Here's land, which we're going to code as a 0. We were looking for water here, remember? Remember what we're looking for. The final cause of this whole analysis is water. Look at that, just twice I picked up land. Oh, is that a water? No, not a land. I want to show a water. Even Leslie lands here. There's one. Skulking around. Here's a water. Okay, blue. All right, fine. That is a representation. It isn't actual land. It isn't actual water. And we have rational consciousness that allows us to do these sorts of abstractions and represent enough of the reality that's outside of our minds that we can then sense and bring in. And there's a lot of controversy about that. Okay, we're just going to be very practical here. We're just going to count, and we did. We're going to transpose this. Now, I also used a cool logical approach, and I see that Richard McElreath is using this in statistical rethinking. You should check that out on GitHub. Great course, marvelous, truly iconoclastic, breaking up the images, if you will. Using logic, taking our grid of what happens when we find land versus hypotheses. There are 4 ways of getting 100%, 0 ways of getting no percent. That's water, and this is land, just in the opposite. And I think I mentioned in part 1, but I didn't mention his name. Might have muttered Mark Garman. See, I'm trained in financial economics and engineering. Engineering is strapping pieces of financial objects together to form a new and hopefully value-adding piece. This is otherwise known as a contract, a portfolio. Mark Garman pioneered a method which basically is based in logic. Well, that's not too surprising because Mark Garman comes from a whole theater and arena of Edwin T. James. Those are all physicists. And on one round, we come up with this quadratic when we multiply those together. And then we add new data. And when we add new data to it, another land notice, the curve changes. It starts to concentrate around some number. And if we add more and more data, this curve will concentrate. And eventually, if we add lots more data, it's going to look like this. And I said we're interested in the entire curve. Well, we might have 1,000 proportions here, stretching from one horizon to the other, and the horizon is at 0, 1. And the number of ways is still the density. The density of ways. It's going to be up to 1,000 minus 1, up to 999 at the top and 0 at the bottom. Now, in the Let's Getting Started piece, which is ground zero, lecture zero of this course, I mentioned extremistan and mediocristan. This is mediocristan. And this is, of course, the language developed in conversations between Benoit Mandelbrot of fractal fame, as well as Nassim Taleb of financial engineering and trading fame. Okay, can you get extremistan in this model? Yes, you can, but we're not ready for that yet. No. Let's just calm down a little bit and do this. The only other thing I want to illustrate here in part 2 is what we're going to build. And I always recommend to people building anything, make a blueprint. And here, the blueprint's going to be a little wireframe. And we're dealing with an implementation device called spreadsheet, and it has cells, which to me is matrix arrays. Okay. It's got rows and columns. The wireframe has a bunch of components. It actually has 3 components that we should be worried about, concerned with, think about. One is the hypothesis component. The other is data. And then data collides with hypotheses into the number of ways. Well, there's actually a 4th piece, which is inference. I'm just going to put it over here. I'm going to give that the name probability. It's always going to be a zero between 1 and a number between 0 and 1. And when you add all of these probabilities up, they're going to sum up to 1, their norm, which allows for common size relativity among this. We're going to be able to, it isn't relativism, it's relativity. It's a fundamental notion and technique inside of analysis that allows us to compare one thing with a big thing with a small thing. Okay, an index, fundamentally. Okay. But it's a bounded index between 0 and 1, with all sorts of fractions in between. Some are rational, maybe some are irrational. Square root of 2. 1 over the square root of 2. But that's neither here nor there. What is absolutely here and there is this is what we call our heuristic structure. The way we're going to discover or think about how to understand data and our view of that data. Data cannot speak by itself, strictly speaking. It's just data. It's just out there. It's already out there now, real, period. It has an intelligibility inside of it. We have to discover that intelligibility. It can be understood, but somebody needs to understand it. The data won't understand itself. It's not endowed with rational consciousness, let alone intellectual consciousness. Maybe sense consciousness. My cat has that. My cat is wondering about the intellectual side, can put things together and come up with a conclusion and act on it. Yes, very much rational. Wondering, a little piece of that. Yes, my buddy James, the cat, prioritizes, no question about it. But I'm not going to reduce my rational consciousness to his, as much as I love him dearly, and I think he kind of cares for me in some way. He cares about me, especially when I don't feed him exactly what he wants. Okay. Heuristic, it's Greek, yes. It's the same one that our Archimedes came up with eroika. And I apologize to all Greek speakers out there. The first person perfect of Erisco. I found it. The foundation of all insight. This is our heuristic. Let me go straight to the this is baseball. We don't want to talk about baseball. We want to have a whole new palette on which to work here. A blank workspace. There we go. Software engineering and development life cycles are very much engineering. Okay, you develop something. So we're going to be doing that here. We're going to be putting all of that in one sheet, whole 9 yards. We're not going to have any real graphics yet. Okay, that'll be another story at another time. But I want to basically put in H here. I want to put in water here, land here, and we're going to go through 1, 2, 3, 4, 5 hypotheses. And as you recall, with 5 hypotheses, we had 4 possibilities. Well, it was 0 for water and 4 for land. And then we went to the second hypothesis, 1 possibility if we pick up water, and 4 minus 1 is 3 more possibilities. There must be land, because that's all we're considering here. I don't like set theory personally, by the way. I was always set against set theory, although I had the Mary Dolciani series of books during my mathematical upbringing in high school. But a favorite of mine was Richard Feynman, who wrote a very influential article about how nobody really uses set theory in the real world. Well, in a sense, that's true. But we do think in terms of groupings of things and how they connect or how disparate they are. Yes, we do. Set theory. But I prefer to stick with the logic. And but the set theory thing here is the complete space, if you will, the manifold off of which we're working. Is 4 things. 4 lucky charms, we hope, inside the bag. We just don't know whether they are blue or green. That's all. And so if we have, our hypothesis is that there's 2 in there in that bag. 4 minus 2 is 2, 10. 3. And I can parameterize this as equals 4 minus 3, just like that. Or I could put it up here and make a parameter out of it. What does the bag contain? 4 possibilities. More than that, I can select those 2 cells, go to formulas, create from selection on a Windows-based PC. It's a little bit different with the Macs. You see it checks off the left column. I can make a variable called bag. What's in the bag? And furthermore, I can do this. And I love doing this because, again, it's visual. And I've got to have other humans look at this and say, can they understand what's going on? There we go. What's in the bag? And I could say 0, 1, 2, 3, 4 here. Okay. And write a formula that says equals bag. Notice it comes right up in context. Make a space for my older eyes here, minus space, whatever's in water. And then Control C, Shift down, arrow, and I create a formula-based approach. Which is getting closer. A heuristic approach now is being filled with an algorithm. And that's how I like to use it. My goodness, I got to be very careful because there's a lot of people don't think about heuristics and algorithms. Most heuristics are like rules of thumb. Yeah, you're kind of right. And algorithms are king. Yes, and well, I'm also dialectically trained. No, let's keep that conversation going. So that's hypothesis. And we also had something called P, which is the proportion. And this too, we can parameterize. We can say it's the number of water possibilities divided by bag. And that's 0. And let's give it a decimal. I like just to use number. And it automatically forces it to decimal places, and just copy this down. And there we go. I've got that. Now let's fix this up here. I'm going to center these. It isn't just making it look pretty, although pretty printing, pretty graphics is a technical thing. There we go. It's a little easier to read. For me, that's what I want. And I could do other things as well. One of the other things I can do is I can say, what is the formula in F7? We will forever wonder why, and I know why row column, it's column row. Now, most matrix, all matrix operations is that I was taught is row column, RC. This is exactly the opposite. It's like reverse Polish notation versus what we call standard notation. HP 12Cs were reverse Polish notation. If you don't know what that is, look that up. It's the way APL was written because it was easier for the computer at one time, and actually meaning more efficient. In F7, what is the formula? Equals formula text. Notice it comes right up. And space, and just go up here, another space. And you get the text there. And of course, you know what I'm going to do. I'm going to make that. Okay. So you can do that all the way around to document. And documentation is really important. Don't write models without documentation as you go along, especially with spreadsheet models, because everything's all over the place. It's what you see is what you get. Well, the other thing is everything's all over the place. You got to be very careful and devise a way. So we pretty much have everything we need on the hypothesis side. Now we go to the data side. And I'm going to simplify our data. We go, how many lands and how many waters? Okay, that's the simplification. You can go back and see that it really doesn't matter. We can do it longhand as we did here. Normalize, make normal. I still don't like that. Rationalize. Oh, we can't use that. That's a psychological term. All right. Here we had columns of 0 to 4, 4 to 0, and then another 0 to 4. Okay, and put those columns together. We can do that here, but there will be a simplification that we can use. And it has to do with powers. It's water to the second power and land to the first power. And powers are just multiplications, right? Anything to the second power is something times itself. And something times itself times something else to the first power, okay, fine. powers are just that. And like I said, we're going to keep this really basic. So, and sometimes this happens to me, and I'd like to get rid of it. And there we go. Ooh, development here. I don't want to use that either. All right, fine. Writing some code these days. So we have water and land. Now watch this sleight of hand. It's going to make things a little easier, maybe for me, less so for you. But that's the way it goes. And this too is parameterized as how many waters did we have? 2. Because they can go in any order. Why can they go in any order? Because multiplication is commutative. Doesn't matter what I put first or what I put second. Beautiful. Commutivity. There is a reason for learning algebra. Yes, Miss Thames. She was right. And one land. So watch what happens when I play with this. I'm going to make these into named ranges, variables, anywhere else. I'm also going to put a little home around it. There we go. Fine. So that when I go here, how many waters were there? 2. These are going to end up being exponents because we're going to take water times land. Well, that's water 0 to the second power times land to the first power. That's our trick. So we're going over here to water, and we're going to raise it to the number of waters. Notice it nicely lights up. And land, I'm going to go over here to land at the 4. Wow, 4 different ways of doing that, but it really doesn't matter this time around. Raise that to the number of the land. Okay, 4. And we're going to copy and paste this all the way down. Control C, shift down arrow, and there's our numbers. Pretty incredible, huh? Okay, so we just mashed together data and hypotheses about that kind of data. All right, that's a mind game. But we're not going to project our mind, as James keeps saying, mind projection fallacy, on our reality. We know this is water, we know this is land. We are making suppositions, we're thinking about it, and we're looking for the intelligible structure that might be in the process of finding water on a planet and estimating. That's what we're trying to do, estimating the proportion of water. So that's done. What do we do next here? We multiply these, we'll just call these ways. Multiply it all together using our multiplication principle, which is our counting principle. That happens 0 ways to get 2 waters. And for each, this is the multiplication language. For each way, there are to get water, there are 4 ways of getting the one land. Now, if there were 2 lands, it would be 16, right? 4 times 4. And so it still ends up being 0. All right, fine. And we have our same 3, 8, 9, and 0. Now, one thing I didn't put in that I needed to put in, let's show you how to do that, was the prior. The priors are experience that here 1 indicates that it's entirely possible, not certain, entirely possible logically, to have 0 or 1. Okay, that's what we're assuming with the prior. So I just put this here and do an insert of columns, and I can correct. Oh, that's nice. I copied that over. I'm going to call that prior. I'm going to put a 1, 1, 1, 1, 1. Now, this is in official Bayesian empire work. This is an improper prior because it doesn't add up to 1. Priors is supposedly probabilities, but we're going to get to that almost next week, but really the week after that, when we take this model and put it into a proper probability framework. So those are the number of raw ways. Again, this is just counting. All we're doing is counting. And one thing that we did with these is we wanted to make them relative. So I am going to sequester something here. Let me do this like this. So I'm going to make all of these hypothesis grouping. Again, I want to emphasize that there are different pieces of this thing that we're doing. And this is the mashing of teeth. No, mashing, not gnashing, of data. We have 2 waters and 1 land with our interesting notions here. And the number of ways, I had to actually multiply this times the prior. Well, it won't let me. There it goes. And this by its prior. You said, well, why don't you just copy and paste it? Well, there's a reason for everything. There we go. There we go. And this is formatting. And this, what you see is what you get as WYSIWYG. Trying to make it as tabular as possible because it's a good way to think. It's an association table, actually, associating something with something else, partially. And we could do that. Okay, now the other thing we did was we wanted to come up with a plausibility index. And the plausibility index is a relative index. It allows us to look at one hypothesis relative to another in an ordered way, not in this slightly disordered way. 3, 8, 9. We know that's going to be the winner. Yeah, no kidding. And one way we do that is we can sum up. We'll call this sum, and this will equal sum of the ways. Let me count the ways. I added something. There we go. And of course, you know what I'm going to do with this. You know, what borders around it, so it's its own thing. And not only that, I'm going to go to formulas, create from selection, and do a, I want to call this sum. Not a great name, by the way, but good enough for our purposes. And that's good. That kind of emphasizes what it is. Now, plausibility is saying, relatively speaking, it's 0 out of what? 20. Remember, we did that. Don't hard code 20. No, it might change when you change assumptions of the analysis. And there are a couple of interesting assumptions of this analysis. Waters and land and 1 to 5. That's an assumption, but we'll keep that. And P will therefore always be 25, 50, 75 in between 0 and 1. Okay, fine. Priors can change and data can change. Your beliefs, your expectations, your tabletop simulation. Done a lot of those. And what we want to do, it came up general. I want to make it a number. And there's our numbers. Okay. And this should have done this. I put a 0 in it. Look what hard coding does. Ruins your day. If I do that, it comes up as sum automatically. That's really what I want to have. Let me just copy this down. Notice I don't drag with this because that's a source of extreme operational errors, which I'll basically lose my job eventually. By becomes cell, 0 becomes 1. Whoops. Lost their minds over that. Okay, and finally, we've got this. And we're nearing the end of our travail together. Part 2 is about to end. And we can picture this, of course, using a graph. But as I said, we're going to do that another time. What you might want to do to play with this a little bit, instead of 2 waters, we found 5 waters. Wow, look at how things changed. They're concentrating more to the 70 plus. Well, what if it's 2 lands? See, moving away from it. Does that make sense? Can you make sense of that? If you can't, something's wrong with your analysis. Okay. The plausibility numbers have to be between 0 and 1, and they have to add up to 1 in order to be consistent with one another. Common size consistency. People call that normalization. I never like that because, well, I don't think anything is truly normal. I think it's again another figment of the imagination, and it projects. It might project the wrong idea in an investigation of anything. So be careful of how you use your language. But what happens if things flip here and this becomes 5? By the way, it costs money to do this, time and money to do sampling. There we go. And you see it flips. It's now in the other direction. Does that make sense? Yeah, because we have more land, less water. We're in a 3 versus a 1 situation. Okay, look at these ways. They're getting huge, right? We're going to have to solve that numerical problem. What happens if I sample this? Watch this ridiculousness. 100. Oh, there we go. Scientific notation. And 1,000. Yeah, it doesn't work. We blew it up. We broke the model numerically. I love breaking models numerically because it tells me where my limits are, and I need to know what those are. Wonder if 200 will work here. Yeah, look, that's 10 to the 120th power. So we're going to have to come up with a better method than this when these numbers get big. So we'll go back to 2 and 1 and stay nice and cozy with that. Okay, I think that's it. We want to name this, of course. We want to name the sheet. We're going to call this sheet analysis. We would probably be putting all the data and standing data, which is 4 bags full, sir, and the land data and the prior data. All of that will probably be located in another spreadsheet, which we will call data. That's good spreadsheet engineering. two different tasks. One is collecting data, and that's a collection. And the other is analyzing the data. So that's what all this is about. Two different analytical tasks, two different tabs on my spreadsheet. Let's save this. I should have done that before. Well, it auto saves as book one or something of that nature. Save as. Where do I want to save this? Oh boy. Don't want to go here because I'm going to create a new thing. First spreadsheet of the new year. Actually, the very first spreadsheet I've done this year. How long did it take for me to do that? Okay, yes, 22S for 22 spring. Week 1, we're going to call this lecture 1, part 2, counting. Okay, so I might recognize it. And that's all it is. So we just cap what we've done here, spend half a second more or two. Well, more than that. We did all of this. We built this spreadsheet and we played with it. We also did updating by simply adding. We used the insight that our mathematical technique of multiplication came up with. It doesn't matter how I mix and match the blues and the greens. Over here, that stays pretty constant. But over here, when we count the ways, it doesn't matter what the order is. And that's going to be a fundamental insight that we're going to use, something called the binomial distribution. Just to finish things out here for lecture 1, we posed a question. Good. Formed an hypothesis. 5. And priors. We got a sample. Wonderful. We counted the ways. Wonderful. And we inferred relative plausibility across the entire range of hypotheses. Not one, not another, not just the best, but the ones and the tails as well. And we discovered that things, as you update, this is a really important point, things are going to get tighter and tighter and more concentrated until you change the priors, until you change the data. We also learned a little something about spreadsheets. 2 different analytical tasks deserve at least 2 different tabs on the spreadsheet for good, clean fun, good, clean engineering practice. And that's prevailing recommended practice. Not a nice thing to do, not a cute thing to do. You should do it. Strongly recommended. Some people used to call that a leading practice. I never use best practices. I was always enjoined by general counsel never to use the word best in anything, because that means that's it, we're done. Got to walk away because it's the best. All right, and we can expect the best, and then we can define that almost any way they want, because we are transcendent beings. We just transcended a relatively simple problem and totally blew it totally out of proportion. Yes, good. Let's do that again with lecture 2, which will be about what I will label probability for real people like you and me. We're going to look at it literally an open outcry labor market here in the Bronx and weather. That should be real interesting. We're still going to use binary data. We're going to use binary data for 3 weeks, 3 lectures, 3 weeks. That too will be part 1 and part 2. So you can look forward to that on the Stats 1 YouTube playlist in Bill Foot's channel on YouTube. And with that, stop sharing my screen. and say, make sure you have your bag of Lucky Charms. Try building the model. Here's the exercise I would propose is build a model with more than 4 charms in it. With, oh, I don't know, 8, 9 charms. Usually pick an even number and it'll come up with an odd number of hypotheses because you're always going to include 0 and 1, right? Yeah, okay. I'll leave you with that and thank you very much for your kind attention.